Hi, welcome to the OpenPLC channel. I hope you've enjoyed our videos so far. Today we're going to talk about PLC drivers. Driver is that magical glue that connects your PLC program to your hardware, the hardware that runs your program. For pretty much all commercial PLCs closed source, you don't have to deal with drivers. You don't have to know how they work or where they are, because those things are set by the manufacturer and closed so that you can only use them. If there is something that is not supported on that platform, you have no luck, right? You have to buy a different PLC or try to see if there is any vendor magic that will have that sensor connected to your PLC. But OpenPLC is open source. That gives you the power to modify, change anything you want, including the hardware drivers. With this in mind, I created something called Python SubModule, or PSM for short. PSM gives you the power to write drivers using Python, a very high-level language that anybody can use. PSM allows you to change the way OpenPLC interfaces with your hardware platform, with your hardware driver. There are pre-built drivers for many different platforms like Raspberry Pi and the slave devices, as you have seen on other videos. But with PSM, you have the power and ability to change all of that and to create your own driver. With this, you can, for example, read sensors that are not officially supported by the OpenPLC drivers. You can create different ways to interface with other hardwares that are not officially supported. So today we're going to explore a little bit of the PSM world, writing a Raspberry Pi driver that communicates with an analog sensor that is not supported on OpenPLC. I hope you enjoyed this video, and please don't forget to subscribe and like this video so that we can have more content coming. Also, don't forget to support our project on Patreon as well. All of this wouldn't be possible without our sponsors that are constantly helping us create more content and improve our project. Thank you very much. Okay, so today we'll explore PSM capabilities by writing a custom driver on the Raspberry Pi that will be able to read an analog temperature sensor. I'm here on my Fedora setup, but the same thing would work on Windows or Mac OS. I'm just using Linux today for variety. As you all know, OpenPLC works on all three major operating systems, Windows, Linux, and Mac OS. I have my Raspberry Pi connected to my network here, and the first thing I'm going to do is to just SSH to my Pi. It's sitting at IP 172.20.10.3. Type in the password, and I'm in. All right. I have my DS18B20 sensor connected to the Pi. If you don't know what this sensor is, it's a digital temperature sensor. It uses a one-wire protocol to communicate digitally with your device. Raspberry Pi supports one-wire devices natively. You just need to enable the driver for it to work. So if you don't have enabled that yet, the way to enable the one-wire driver is to just launch the Raspi config utility and then go to interfacing options, and then select one wire here. I'll just select here, and it asks me if I want to enable one wire interface. Just be cautious with this question, because if you answer no, it's going to disable the one wire interface if it was already enabled. So here's a yes/no question, but yes enables it and no disables it. There's no cancel here in this dialog, okay? So I'll just select yes, make sure that this one wire setup is enabled, and go to finish, and it will ask me to reboot. While I wait for this Raspberry Pi to reboot, I'm displaying here a picture of how I'm connecting my sensor. There are plenty of information on the web on how to connect a DS18B20 sensor to your Raspberry Pi. This is a very cheap sensor, widely available, and works very well, super reliable to read temperatures on the Raspberry Pi. This is quite useful for the Raspberry Pi because the Raspberry Pi has no analog inputs, as you all know. So when you're using OpenPLC with the Raspberry Pi, you can only trigger GPIO pins, digital pins. And a lot of people ask me, can I use any analog sensor with the Pi? Well, natively no, because the Raspberry Pi drivers only controlling the GPIO pins, and they're all digital. But using drivers like PSM, you are able to interface with more intelligent sensors like this DS18B20 using one wire. Okay, I think we've waited long enough. My Pi has probably rebooted already, and I'm logging in again, and here I am. Now, to make sure that I have my one wire module enabled, a command that I can launch is lsmod grep w1, and it shows me that it has in fact loaded my one wire with both the one wire GPIO and one wire therm modules with that. So this is sufficient if I want to read my digital temperature sensor. Okay, I can test my setup now on terminal and make sure that everything is working. Because this is a kernel driver, I can interface with this using the sys bus path. Here I have a lot of buses that are enabled, and I can go to the W1 or one wire bus and go to devices, and here I see two devices. This is the master bus, and sure enough, this is the device that I have connected. So if I CD to that device, I do have one file here. In Linux, everything is a file, right? So I have a file here that actually has the temperature read by that sensor. I can just cat that file to read the temperature here on the terminal. And sure enough, you see here that it reports back the bytes read, and this is the temperature. T equals 26,375, which means 26 degrees Celsius, 26.3 degrees Celsius. Can repeat this and continue reading that temperature. It's pretty steady right now. You see that communicating with the sensor takes a little while. That's because one wire is a slow protocol, and you're probably wondering how that would affect your PLC runtime. Well, PSM is a threaded driver, which means that if you mess up and you're just waiting forever on a measurement to read, it's not going to affect your PLC scan cycle loop, right? Because it runs on a separate thread. But we must be wise when we're programming drivers to make sure that slow measurements are not affecting other measurements that we're making on that driver, right? So we're going to discuss this once we start writing our driver on PSM. But just keep that in mind, that this is a slow measurement. You see, it takes about 1 or 2 seconds to give me back a temperature measurement. Now that we see that our sensor is working, we can proceed writing a driver for it. Because PSM is based on Python, let's first write a quick Python program to make sure that we can interface with the sensor from Python. I'm going to use a common Python library to read those one-wire sensors called W1 therm sensor. If you don't have that installed, a quick pip3 install W1 therm sensor will do the trick for you. So as you can see here, I have mine installed already, so there's nothing to be done. I'll just then start a new Python 3 terminal. Just make sure you're on Python 3, not Python 2, because PSM uses Python 3, okay? So with this, let's just use from W1 therm sensor, import W1 therm sensor. Okay, now let's just instance the object here. A sensor equals W1 therm sensor. All good. Now with the sensor object, I can easily read my one-wire sensor temperature. Just call sensor.getTemperature, and here I have it. Okay, can repeat the command as many times as I want. So this is perfect to use on a PSM driver, right? Just a couple lines of Python code. I can read my DS18B20 sensor, and as you saw on the terminal, it still takes a little while to read the temperature, just because this is a slow sensor. Okay, so let's exit from here. Now I'll make sure that OpenPLC is running. I don't think it is, so let's check this with system control status OpenPLC. It's not running, so let's start it. System controls start OpenPLC. All right, now I know it is running on my Raspberry Pi, and I can go back to my terminal or to my browser here. I'm using Firefox here on Fedora, and then just go to my Raspberry Pi IP address. That's 172.20.10.3 at 8080. And here is my OpenPLC login page. Just use my username, and good. I am inside the Raspberry Pi. Now, on the hardware tab, you will see that this Raspberry Pi is using the Raspberry Pi driver. If I want to enable PSM, I will have to select Python on Linux or PSM on the bottom here. Just beware that if you enable PSM, you're going to lose your Raspberry Pi original driver, which means that you won't be able to control your GPIO pins unless you write code to do so. So if you want to control any of the GPIO pins on your Raspberry Pi, you will have to write Python code to interface those pins, because PSM is replacing completely your Raspberry Pi driver that controls or interfaces those pins. Okay, so as you can see here, you have a box to write some code here in Python, and PSM code is already filled here for you. The code is pretty simple. Everything starts here on their main function, and it initializes your hardware. If there's anything you need to do before reading or writing to your peripherals, you'll have to place those commands here on your hardware init. Okay, and then after your hardware is initialized, you have a infinite loop here while PSM is running to update your inputs, update your outputs, and then sleep for a little bit. Since we're dealing with an input sensor, we're gonna go to the update inputs function here. The default code for PSM implements a little counter here that we're gonna toss out. This is just for demonstration purposes. If you're reading our sensor, we're doing something different. So the first thing I will do here is to just go up here where I declare some global variables, and I will declare my sensor variable here. Sensor equals none. I'll not initialize it here for now. I'll toss this var state variable because I don't need it. And then on my hardware initialization function, remember that this function is only executed once when PSM is booting up. I will put my sensor equals w1 therm sensor call. But for that to work, I also need to import my, or let's do it better, from w1 therm sensor, import w1 therm sensor. All right? Now I have everything I need. I imported my library, I created my global variable, and I initialized it here. It's a good practice to just declare it as a global here as well, right? Okay, now I can play with it here on my update inputs function. Again, I can set the global sensor, and next step is to just read the temperature using this sensor object. So I'll just call it temperature equals sensor dot get temperature. This function will return a string to me, right? I need to convert that string to integer so that I can place it on OpenPLC buffers. I'll do this by just calling temp int equals temperature, or better, int temperature. Oh, good. Now I have my temperature as an integer inside my temp int variable, and the last step is to just set a PLC variable with the value of my temp int variable. Okay, so I'm gonna set IW0 because that is a location that can hold 16-bit values. Okay, so it's not a digital on-off switch. And I will place my temp int quantity in there. And that's all I have to do, right? I'll just toss everything else. And now I have my update inputs. That is just using my global sensor to read the temperature from the sensor inside this temperature variable. I'm transforming it into an integer and then writing it to IW0. For the update outputs, I'll just delete whatever is in here. I'm not doing anything with outputs. I'm just reading that sensor on IW0. And I have my driver ready. Now I can just save the changes and it's going to compile my final project. Okay, so I don't have a PLC program to display or read that temperature yet, but because I wrote a driver, I can just start whatever PLC program it was running to make sure that PSM is loaded up correctly and that my Python code is okay. So let's just start the PLC here. And sure enough, I have a problem. It's an indentation error on my main function. So let's go back to our code and see where the problem is. I'll just stop the PLC here. Okay, go back to hardware and check my PSM code to see if I messed up with any indentation. It's probably because this code is using spaces, and at some point I might have used tabs for it. Looks like, oh, that's because I removed the contents of my update outputs function, and because it has nothing in there, Python is just waiting for some commands to process inside that function. So I'll just type pass here so that Python would ignore that function call. I'll save changes and try that again. Okay, go back to dashboard and let's start my PLC again to see if the PSM driver is working. And we got another error, and this time the problem is actually because the W1 therm sensor is not installed. The problem is that when installed it on our user Python 3, we now need to install it for the pseudo user because OpenPLC is running as root. So we need to install it for the root user. So let me stop the PLC again. Let me go back to my terminal and I'll do a quick sudo pip3 install W1 therm sensor. Alright, so this is now installed on my Raspberry Pi for the root user. And let me start the PLC again to see if this time it's going to work. Alright, no more errors. I see that PSM was started and OpenPLC is connected to PSM. Everything looks good. Perfect. Now I need a program to be able to read that value. Right? The current program slave test has nothing to do with analog inputs. Even if I go here in monitoring, I'll see that it's only dealing with Boolean logic, so it's not doing anything here. So let me stop the PLC and let's go to the OpenPLC editor here real quick to draft a little project that will deal with our thermistor, with our digital temperature sensor. So I'll just create a new project here on my documents, PLC programs. That's where I like to place them. So I'll create a project called DS18B20. And that's the place I want to add it. And my new program is temperature. That's what I'm gonna call it. It's gonna be in ladder logic, and this program will be quite simple because I'm not focusing on the PLC programming here today. I just want to show you guys how to use PSM to write a nice driver. So all I will do on this program is to add a new variable called temp, and that variable is of type integer, and it is located at IW0. So this variable is located exactly at the location where I'm storing my temperature measurements using PSM. Okay, so I know that my readings should sit there on my word input location 0. And I'm not going to do anything else on my program here. I just need to create a variable here so that the compiler won't be mad at me at no location. Okay, so this is a very simple PLC program. Let me just test it. It shouldn't do anything. Okay. And indeed, it's not doing anything. I can force it to true, and it will just sit there. But what matters is that I have a variable here in my program that is located at IW0. That's where I want to read my temperature sensor. Okay, so all I will do is to compile this program on my Raspberry Pi and then monitor it to see if my IW0 really has my temperature value. So let me just compile it for the Pi, and then I'll go there on Documents, PLC Programs, DS18B20, and I'll call it temp.st. That's the name of my program. I'll save this. Now that I created my program, I'll go back to my Raspberry Pi here on OpenPLC and upload this program there. Load a new program. Go to Documents, PLC Programs, and upload the temp.st. I'll call it temperature on PSM, or better, with PSM, and just upload it. Alright, so as you can see, it only has one located variable that is exactly at the location where I put my sensor reading. Let's start the PLC program now, and everything looks correct. I have PSM started, connected to PSM. Now let's go to monitoring and see what it looks like. Nice, so I have my nice little 27 degrees sensor reading here on my monitoring. If I get the sensor and breathe close to it for a little bit, you will see that that temperature starts to rise according to my body temperature. Alright, so yes, it is working. It's reading in real time. That's analog reading on a Raspberry Pi using PSM. This is just a simple example. Again, you can go back to your hardware and add many other features on your PSM driver. You can add code to interface with your digital GPIO pins, or you can add different digital sensors to any of the other pins. You know, sky's the limit. PSM allows you to do anything you want, any kind of sensor you want to read, any kind of actuator you want to interface, and then after you have your Python code up and running, you just go to OpenPLC editor and design your PLC program around it. Hope you guys have enjoyed this content. There's more coming. Please don't forget to subscribe and like this video so I can have more content coming up fast for you. Thank you so much. See you soon.